So this is starting a new chapter, chapter 8, and so we're getting into some of the applications of integrals in this chapter, and we're kind of keeping these to a minimum in this course. You may see more if you take other courses that use calculus 2, integrals, and that kind of thing. But we're just kind of getting into some basic things, and this section in particular is on what is called arc length. And so arc length just means exactly what it sounds like. We have some graph, some curve, and we want to know what is the distance, or what is the not the distance exactly, but what is the length if you travel along this curve from point P0 to point Pn, wherever that is, or between A and B, following the curve. So how far would you travel? And so it's a pretty simple formula. We will kind of derive this a little bit. I won't spend too much time on this, but just so you know where the formula comes from, it's fairly easy to see, I think. So first of all, so the blue here is the actual curve. And so what we have done is we have divided the curve into tiny line segments. So you pick points along the curve, and then you connect those points by a straight line. Okay. Um, However many you want, it doesn't really matter. But you connect these points with line segments. And so if you want to find the distance between any two of these points, then we can use the Pythagorean theorem, and we'll let S be the distance. So delta S would be the change in distance between any two of these points. And so this Pythagorean theorem, we have the change in x squared, I guess squared should be outside the parentheses, plus the change in y squared, and all that is under the square root. All right, so we will factor out a delta x from under the square root and pull it out. So essentially we're dividing both of these terms by delta x squared, and then we'll pull it out and we'll have a delta x out here. So this tells us that delta x is approximately equal to, now divide this by delta x squared, we get 1. Divide this one by delta x squared, and we get delta y over delta x squared. And then we're going to pull out a delta x squared from under the radical, and we'll have a delta x out here. Now, we have a finite number of these. We have n of these. And if we let the distance between any two of these points go to 0, so we're gonna get more and more of these, and so the distance between the 2 points is going to go to 0. And if we do that, then this becomes a ds, and that's approximately equal to 1 plus dy over dx squared times dx. And so then, as you can imagine, what we're going to do, we are going to add up all these pieces and take the limit to infinity. And this is we're going to call this the arc length, and it's going to be the integral from the left side A to the right side B. So the integral from A to B, square root 1 plus, now dy over dx, that is the derivative of the function, whatever this curve is. So f prime of x squared dx. And so it's a very basic formula, but that's where it comes from. You don't really need to know where it comes from, but if you're interested in where it comes from, that's how we get it. So that's where the one, why is the 1 plus there? Well, it's derived from this original distance formula. Why are we taking the integral? Well, that's because we're getting infinitely many little pieces of this at once. So all right, so we're just going to do one example. These are fairly simple. It's really just plug in the formula. So we have y equals x to the 2/3 or 3/2, and we want to find the arc length from 1 to 4. And so we're just going to use this formula. I'll scroll back up so we can see it. So of course 1 is a and 4 is b, and so we need to find f prime or y prime. So that will be 3/2 square root x. And so then let's just plug this in. So we get the integral from 1 to 4, square root of 1 plus 3/2 square root x squared dx. And so, I mean, sometimes these will look a little bit intimidating maybe when you first set them up, but usually once you simplify them, they're not going to be too bad. So let's simplify this. So we get 1 plus square this, and we get 9/4 x. And of course, this is just a linear function under a radical, which is not a big deal to integrate. We'll use u substitution just to make sure we don't lose any fraction in here. So u is going to be 1 plus 9/4 x. Du is going to be 9/4, not x, 9/4 dx. And so we just have a dx here. So let's move the 9/4 over. So we get 4/9 du equals dx. All right, so then let's do our substitution. So let's change our limits of integration. So if x is 4, plug 4 in here, and we get that u is going to be 1 plus 9/4 times 4, which will give us 1 plus 9, which is 10. And then when x is 1, we get 1 plus 9/4, and that is 13/4. So our new integral is going to go from 13/4 to 10. Square root of u times dx, which is 4/9 du. So 4/9 square root u du. All right, so then we'll add 1 to the exponent, divide by the new exponent, so we get u to the 3/2. We'll divide 4/9 by 3/2, and we get 8/27. U to the 3/2, and that is evaluated from 13/4 to 10. Now we can just plug this in, and we're not going to simplify this. We'll just leave it 8/27 times 10 to the 3/2 minus 13/4 to the 3/2. Now, I will say this, one thing I noticed this on the test for a few of you, and going forward, I'm sure this will still be an issue as we go forward in the class through different semesters. A lot of you are tempted to put this in the calculator and get a decimal approximation. This is what you need to put. So you don't need to simplify this. It doesn't say, so it just says find this arc length. This is the arc length. So it's not a very nice looking number. It doesn't really give you much information. If you're not putting this in the calculator, I understand. But this is all they want. This is the answer that you need to put in. So if there's a way to simplify the answer that you get here beyond this, you can if you want. But in this case, there's not really anything you can do. And so you just need to put this in. Don't put it in the calculator. And just put the answer in like that. Okay, so pretty simple. But if you have any questions, you can let me know.